Hello young friends, we are discussing types of chemical reactions. So far, we have discussed combination reactions. Let's explore further. As you can see, in a boiling tube, I have taken 2 grams of ferrous sulfate crystals. I want you to note the color of the ferrous sulfate crystal. Aren't they light green in color? Now let's heat the boiling tube over the flame of a spirit lamp I have here. Well, first let me light the spirit lamp. Whenever you are doing such experiments, make sure you are doing under the observation of teacher. So here is the boiling tube with ferrous sulfate crystals. Let me hold it with the test tube holder and now place it over the flame. Now friends, recharge your observational skills, and while we are heating, observe the change in color of crystals carefully. And always remember, the correct way of heating the boiling tube is to tilt it at an angle of 45 degrees. And also, never point the mouth of the boiling tube at your neighbors or your own self. Can you see the color change happening in the color of the ferrous sulfate crystals? And yes, the fumes coming out of this may be very poisonous, so you have to be very careful. Never inhale it directly. Can you note the change in the color of the ferrous sulfate crystals? I think the green color has changed. And yes, the crystals are now turning brown. We can also smell characteristic odor, and the correct way is wafting gas gently towards the nose. Never inhale the gas directly. It may be harmful to you. And can you hear the crackling sound? Aha! The reactant ferrous sulfate is breaking down. Now friends, can you see these water droplets on the inner surface of boiling tube? From where have these water droplets come? Well, the ferrous sulfate crystals, that is FeSO4.7H2O, lose water when heated, and color of the crystals change. This process can be represented by the chemical equation you can see on the screen. Ferrous sulfate is shown decomposing into ferric oxide, sulfur dioxide, and sulfur trioxide. Ferric oxide, as you can see, is solid, while SO2 and SO3 are gases. Now friends, put on your thinking caps and tell me what will happen if I keep this moist litmus paper, the blue litmus paper, on the mouth of the boiling tube from where the gases are being emitted. You've already studied in your earlier classes about the change of the color of the litmus paper. So I'm sure you can tell me whether you will see any change in this blue litmus paper. And what would have happened if I would have kept a red litmus moist paper? Think. If not, explore and find out. In this reaction, we observed that a single reactant breaks down to give simpler products. Such a reaction is called decomposition reaction. Okay, now let's talk about one more example of decomposition reaction. You all are very familiar with chalk piece. In language of science, we call this calcium carbonate. Do you know, on heating, calcium carbonate breaks down to form calcium oxide and carbon dioxide? And I'm sure if I ask you, how will you know that this gas is carbon dioxide only? You will quickly tell me that carbon dioxide turns lime water milky. We know that calcium oxide is also called lime or quicklime. And what is the common name of calcium carbonate? Yes, you have guessed it right. It's limestone. And remember, decomposition of limestone is an important decomposition reaction. It is used in various industries. One I am going to tell you, and that is in manufacture of cement. You may explore a little and find out its other uses. As I told you, you are discoverers. You may explore through internet or may visit libraries nearby or your school library. I'm sure it is full of books. And always remember to share your books with your peers. Now, these two reactions which we have done, we observe that for breaking down the reactants, energy was used. Which form of energy was used? Yes, you saw it. It was heat energy. Now, can we now define it? When a decomposition reaction is carried out by heating, it is called thermal decomposition. To understand this better, let's do another activity. Here, I have lead nitrate powder in a boiling tube. As students of science, always remember to use chemicals judiciously, as they ultimately go into the drain and harm the environment. So here, I have just taken 2 grams of lead nitrate. Let me heat it over the flame. And here I am reminding you, never do this experiment on your own. You should always do it under the assistance and guidance of a teacher. I am holding this tightly with a test tube holder and I will be heating it. Again, keeping this, remember, at the angle of 45 degree. And yes, note the color of the lead nitrate, because slowly there is going to be a change. This is what the magical world of science is about. Again, I can hear crackling sound. That means the reactant has started breaking down. And yes, children, always remember that the mouth of the tube should never be pointed at your neighbors or your own self. You have to be very careful. Emission of brown fumes can be seen. Look here and be careful. Never inhale them directly. They can be harmful to you. I hope you are noting your observations. These fumes are of nitrogen dioxide. Lead nitrate has decomposed into lead oxide, nitrogen dioxide and oxygen. So as you can see on the screen, lead nitrate, that is 2 PbNO3 whole twice, on heating gives 2 PbO, that is lead oxide, and 4 NO2, that is nitrogen dioxide plus O2, oxygen. And always remember to write balanced chemical equation, and you must also mention physical states in small letter within the brackets. Let's explore further and develop deeper understanding. Let's watch this video. What's happening in this video? For this experiment, the materials required are a stand, we need a bell jar, boiling tubes, rubber cork fitted with 2 electrodes, crocodile clips with wires, and a 9-volt battery. Here, bell jar has been shown with rubber cork fitted with 2 electrodes. First, we have to fill water in bell jar. When we put water in bell jar, care should be taken that electrodes are immersed in it properly. 2 small tubes are taken filled with water to the brim, and we are now inverting them over the 2 carbon electrodes. When you are doing this, care has to be taken that no bubble is formed. Otherwise, we will not get to know about the exact ratio of the gases. Now both the test tubes have been placed over the electrodes. And now crocodile clip is attached to 9-volt battery. Remember, this is decomposition using electricity. So water will decompose by passing electricity. Few drops of dilute sulfuric acid is being added to the water so that reactions become fast. Now look at the video carefully. See, the reaction will become fast here. Slowly, the gases will collect in these. What do you see? Formation of bubbles taking place at both the electrodes. Is the volume of gas collected the same in both the test tubes? In one, you see more gas, but in other there is little gas, because the ratio is different of the gases, that is 2:1. See here, you can see effervescence. Do you know why? Now we will test. How will you verify that the gases produced are oxygen gas and hydrogen gas? We will test these gases one by one. We will remove the test tubes carefully and safely. If we will remove the finger from the mouth of the test tube, gas will escape. Where we get a pop sound by placing burning splinter, it means gas is hydrogen. Oxygen helps in burning. You all know this from your experience. So look here, bringing burning splinter near mouth of other test tube, it is supporting burning. See, the flame is becoming brighter. Have a look at balanced chemical equation of decomposition of water. Here, what do you see on screen? 2H2O gives 2H2 plus O2. Remember, you have learned that balanced equation helps you to do calculations. Look at this balanced equation. The products obtained are 2H2 and 1O2. So you see, hydrogen and oxygen is present in the ratio of 2:1. Now, one thing you need to tell me, which form of energy was used for breaking down the reactant in this decomposition reaction? Yes, as you saw, this is decomposition by electricity. Now, moving on further, here's another interesting observation from your daily life. In market, we get photochromatic glasses. In bright sunlight, their color becomes dark. And when we shift in the room, they again become transparent. Have you ever wondered what is the science behind it? Let's learn it through this video. In this video, you can see we have taken 2 gram silver chloride in watch glass. What was its color? Yes, it was whitish. And it is placed in sunlight for some time. After some time, what changes do you observe in the color of the silver chloride? Silver chloride turns gray in sunlight to form silver metal. This is what happens in photochromatic glasses. In glass, silver chloride and silver bromide are present. When light falls on colorless glass, AgCl and AgBr break into ions, chloride ions and bromide ions, and show its gray and brown color. If their mixture is taken, then we get a mixed shade. As more sunlight falls, more decomposition happens and glass becomes dark. Now, moving away from sun, these ions combine by combination reaction, remember? They give back AgCl and AgBr, which are transparent. Now, we can easily write chemical equation for this chemical reaction. Let's have a look at the chemical equation. It says 2AgCl in presence of sunlight gives 2Ag and Cl2. Silver bromide also behaves in the same way. 2AgBr in presence of sunlight gives 2Ag plus Br2. The above reactions, they are also used in black and white photography. And what form of energy is causing these decomposition reactions? Yes, these are decomposition by light. Let's have a quick recap of what we have learned so far. These 3 were reactions in which they require energy or they absorb energy for breaking down the reactants. So they were endothermic reactions. Thermal decomposition, which we had done of ferrous sulfate. The second was decomposition of calcium carbonate. And the third one was decomposition of lead nitrate. And we also did decomposition by electricity. And now you just now saw decomposition by sunlight. Now observe carefully. I will show you an activity and you will tell me whether it is an exothermic or an endothermic reaction. Here I have taken around 2 gram barium hydroxide in this boiling tube. Now I am going to add ammonium chloride. Approximately, these both have to be taken in 2:1 ratio. So here I am adding approximately 1 gram of ammonium chloride. And after adding it, now I am going to mix it with the glass rod like this. And children, always remember to use chemicals judiciously because they harm the environment. And this can very easily be felt by visually impaired students. They can feel change in temperature. I can feel it has become cold. You can also check and verify by using thermometer that whether the temperature has decreased or increased. Now tell me, here is a small task for you, whether this is exothermic or endothermic reaction. And yes, I can also smell some gas. What gas could it be? Why don't you write the chemical equation? And here is a small task for you. In your kitchen, mix lemon juice and baking soda. Feel it. Does it feel cold? I'm sure you will enjoy being a little discoverer by finding the answers yourself. So you go into the kitchen till I join you with the next interesting reaction. So far, we have done various chemical reactions and you have learned to record your observations, take down the word equations and make chemical balanced equations out of them. And children, always remember to use chemicals judiciously because they harm the environment. And most important thing, that always keep your surroundings clean.